Okay, bonding video number 2. The objective today is to find out the Lewis dot structure of a covalent molecule, including the exceptions to the octet rule. In order to do this, you need your bonding video number 2 worksheet, which was passed out in class and also available on Edline, and a pencil. You need this because this is turned in tomorrow. A periodic table is also helpful. The octet rule, as we said, is that all atoms, after forming a bond, either by sharing, gaining, or losing their electrons, will like to have 8 electrons in their outermost or highest energy level. Exceptions to this octet rule include hydrogen, which we already talked about in the past. Hydrogen always makes one bond and it has 2 electrons. So, for example, water show the hydrogen having only 1 bond and 2 electrons. Other exceptions include hydrogen and the atoms in that first column will all end up with 1 bond and 2 electrons. Most of these will be ionic compounds and won't be an issue. In the second column, they will have 2 bonds and a grand total of 4 electrons. They also will most likely form ionic compounds and will not be an issue. And then the column here with boron, aluminum, and so forth will have 3 bonds and 6 electrons. These are going to make up your last exceptions to the octet rule. Let's try an example. Bi3. Just like yesterday, you want to start off with how many valence electrons do we have? Using your periodic table, boron has 3 valence electrons. Plus, there's 3 iodines. Each one of them has, down here, 7 valence electrons, for a grand total of 24 valence electrons. Next, we want to put boron in the center. Boron has 3 valence electrons. It is the closest to 4. Then the iodines get spread out symmetrically around the boron. We now have 1, 2, 3 bonds, or 6 valence electrons being used. This leaves 18 valence electrons for us. Boron is done. Boron is able to make 3 bonds and 6 valence electrons. He is done. So the rest of the 18 are going to go around the iodines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, you are now done, but you want to double check. First, we have 24 valence electrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs or 24 electrons. That's good. Next, do they have octets? Iodine has 1, 2, 3, 4 pairs or 8 electrons. It has an octet. This iodine also has 1, 2, 3, 4, 5, 6, 7, 8 electrons. It's an octet. The last one has an octet. And boron is the exception to the rule. It only has 3 bonds or 6 electrons. So this is done. Second practice problem in your last one. Beryllium bromide. Beryllium, based on where he is on the periodic table, looks like he would be making an ionic compound. But due to electronegativity rule, he is going to be making a covalent one. So based on the covalent rule, let's do the Lewis dot diagram. First, beryllium is going to end up with 2 valence electrons. Plus, there's 2 bromines with 7 electrons apiece. We have 16 valence electrons. Beryllium is the closest to 4. He goes in the center, and the bromines go on either side. Beryllium is done. Because of where he's located on the periodic table, because of where he is right here, he gets 2 bonds and 4 electrons. He is done. We're going to subtract out those 4 electrons. We have 12 more electrons to go. They're going to go around the bromines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At this point, you want to double check, make sure you used up a grand total of 16 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's good. Make sure you have the octet rule. 1, 2, 3, 4, 5, 6, 7, 8 around this bromine. And 1, 2, 3, 4, 5, 6, 7, 8 around this bromine. And of course, a beryllium has 1, 2 bonds, 4 electrons, and he is done. This is a completed structure. Okay, by way of review, these are called unbonded or unshared electron pairs. The ones in a bond are called the bonded, or it could be called shared electron pairs. That is the end of our discussion about the exceptions to the octet rule. You would want to come tomorrow being sure that you can both do Lewis-Dot structures for exceptions and the non-exceptions, as we have a very vital piece for Monday's work.